Master algorithm and the data structure is one of the biggest steps of becoming a software engineer. However, there are so many topics to learn, it's easy to get lost along the way. Here's my recommendation of algorithm learning path. This is based on my 10 years of experience as a software engineer. So, let's get started. First, we need to understand the basics. What's the basic? The first one is the BigO. What is BigO? BigO is a way to evaluate the efficiency of a particular algorithm. You will use it either to evaluate the time complexity or the space complexity. Once you understand the BigO, then you will move on to DFS and the BFS. DFS stands for Depth First Search. It is a strategy that you go deeper and deeper as much as you could first to find the answer you need. On the contrary, BFS stands for Breadth First Search, meaning you go evenly, one layer by layer, until you find the answer you need. Then, once you have the understanding of DFS and the BFS strategies, you can start to learn the most two fundamental data structures, array and the list. This tool has its own pros and cons in terms of their characteristics. You either implement the array or list in DFS style or BFS style. This is how we should learn it step by step. You always try to combine the knowledge you got previously to the new concept you are learning right now. Next, once you have the sound understanding of array and the list, we can go on to a more advanced data structure, stack and queue. When it comes to stack, you could either implement by using array or by using list. Both can work. And the most important concept of stack is last in, first out. As you see on the right example, this is a chip's example. Whenever you put down a chip, the first one you pick to it will be the last one goes in. On the contrary, if you look at the queue data structure, its concept is first in, first up, just like how you line up to buy a movie ticket. So stack and queue are two often used data structure in many legal questions and even in the real work projects. And then it's a good time to learn the linear sorting. What is linear sorting? It includes some basic sorting you might already heard about. Bubble sorting, insertion sorting, selection sorting. These are the three fundamental sorting algorithms you can learn from the very beginning. They will give you a sense of algorithm without using complex data structures. Up to now, we have fundamental understanding regarding the basics of algorithm. So I would recommend we can learn about the 5 big algorithm strategies. As you see on the right, it includes branch and bound, backtracking, greedy, divide and conquer, enumeration. These 5 algorithm strategies are a good way for you to understand how algorithms help you to find a target more efficiently. And different strategies serve different use cases. So here will be the first step, understanding the basic of algorithm. Once you nail the basic chapter, we can move on to the next one. The next topic I recommend to move on to is tree. Tree is the most used data structure when it comes to legal questions. It is worth the time to understand it. So first, you need to understand what binary tree is. Basically, it means it has a root node, and for its branch, it will have 2 branches as the max branch number. Once you have understand the definition of binary tree, you can try to understand how to traverse a tree. Traverse means go through all the nodes of a binary tree. There are 3 typical types of traversal, including pre-order, in-order, and post-order. Next, binary tree is still a general definition of a tree. To be more practical, we will learn about binary search tree. As you hear from the name, it is the data structure for the well-known algorithm, binary search. Binary search will offer you a great efficiency of searching something. Its BigO is O log n, which is pretty good already. And now you've understand binary tree, binary search tree. Next, you can leverage what you learn about binary tree to implement a more complex sorting algorithm, including quicksort, merge sort, and tree sort. All of these three sorting algorithms are based on binary tree implementations. So this is again how we should learn concepts one after another in an organized, systematical way. With the understanding of BigO, you understand why you should learn binary tree and use binary search tree. With the understanding of binary tree, you can now implement a more complex sorting algorithm, quicksort, merge sort, and tree sort, which gives you an even quicker sorting algorithm compared with the previous linear sorting, such as bubble sorting. So now we also finished the learning of tree chapter. The next chapter I would recommend we tag as hashing. Hashing is a concept where you can convert an abstract, complex data or concept into a concrete object or even a specific number. As you see on the right, this is a complex border with very complex texture and cracks on it. You can use some kind of hashing algorithm to convert it into an easy to understand cube, or you can even convert it into a specific number to represent this original complex border. So this is the basic high-level understanding of hash. In the hash topic, we first need to understand its definition and where it's used. Second, we need to have the ability to customize the hashing function you are gonna use. For different use cases, we need to have a customized hashing function to help us convert an original object to a specific number. And then you will encounter a term called hash table. It's nothing more than just a hash key with the target object you want to map to. So you can use your hashed number to find a target object in a very efficient way. How efficient it is? It's actually better than binary search you see on the left. Binary search gives you a BigO of O log n, while hashing table will give you a BigO1 algorithm efficiency. It's super quick. So that's why our third topic should be hashing. And next, you can see from time to time, the hashed value you generate might be a duplicate one. That's where you need to handle the hash collision. To really leverage hashing in a production environment, handling hash collision is the crucial step. Next, hash search is also one of the ways to leverage hash table. For instance, when you are accessing an element in an array, you are using the index. Basically, this is the same concept of using hashed key. The index here is the hashed key to an array, so you can quickly find the element you need in a BigO1 time complexity. So with the hashing concept in our hand, the data structure that are based on hashing are set and map. Both of them leverage hashing as its core implementation to give you a quick lookup of a specific element. So now up to here, you probably have already spent like 1 to 2 months. We have still 3 more topics to learn. However, I would recommend let's take a break here. We don't need to rush into learning more new stuff, but it is a good time right now to practice what you learn. Now I would recommend you find some LeetCode questions with the easy level for each topic here, basic, tree, and hash. Maybe find like 5 to 10 questions for each topic. You'll get a better understanding and a hands-on practice to be more familiar with all these fundamental concepts. Especially you will get a chance to implement those data structure we see here, such as the binary tree, binary search tree, set and map, and all those sorting algorithms. For everyone who is good at algorithm, they must have done so many coding themselves. So now, with the practice on the LeetCode questions, probably another month is spent on it. So I would say you spend 3 months up to this point for these 3 topics: basic, tree, and hashing. If you still have your life, you can finish it in 1 month if you don't eat, don't drink, and you don't go out at all. But let's say you are a typical person. Right now it's about 3 months. After taking a good rest, let's move on. The next topic I would recommend we to take up is balanced tree. What is a balanced tree? To understand this concept, let's go back to the binary tree we have learned before. When we are talking about binary tree, we actually always has an assumption. This tree is always balanced, meaning they will look typically as you expect. However, let's imagine if you have a tree that go all the way down to the right, it will look like just an array. So even though it fits the definition of a binary tree, it doesn't really provide you the advantage of using a binary tree. For the binary search of a very tilted tree, it will give you the worst performance of BigO as a result of your binary search. So in order to really leverage what binary tree has, you need to have a way to guarantee your tree is balanced. So this is the 4th topic we should take up. However, this is a more advanced and a complex concept to master. So it's gonna take more time to understand and to practice. In the topic of balanced tree, the first one we are gonna see is binary heap. Binary heap is also a very common data structure you use in the LeetCode questions. Some people just call it heap. It gives you a way to get out the max element or the minimum element in your data. Aside from binary heap, you will also start to learn about the concept of AVL tree, 2,3B tree, 2,3,4B tree. Up to this point, the max branch number of a tree is no longer just 2. It could be more than 2, such as 3 and 4 here. And the last data structure you should learn in the topic of balanced tree is the well-known red-black tree. Red-black tree is a commonly used data structure in many real applications nowadays. The way how red-black tree is implemented is a very interesting one to learn. You probably will not be asked to implement a red-black tree in a real coding interview, but learning about the concept of how to implement it is a very good way to help you advance your algorithm knowledge. So now we finished the understanding of balanced tree. You will have a higher confidence when it comes to tree, because you know whenever needed, you have a way to guarantee a tree is balanced. Let's move on. The next topic we can pick up is graph. So first, let's link the concept of tree to graph. So on the right, you will see this is a rooted tree, meaning we define one of the nodes as the root, and everything will go from here up to down. This is a typical tree we actually see before, either in balanced tree topic or the binary tree topic. And now let's imagine if there's no root. In this one, we have no node defined as root. So each node is equal to each other. So we can kind of say this is an unrooted tree. You will see it's more like a graph now. So actually you can see tree is just a subset of graph data structure. So that's how we kind of go to a bigger topic here, from tree to graph. So to really learn about graph data structure, you will need to continue to know what is directional and what is not, and what is cyclic or acyclic. So whether a graph is directional or cyclic, you will divide the graph into 4 types: a directed acyclic graph, undirected cyclic graph, directed acyclic graph, directed cyclic graph. So more than that, to understand the graph, we also need to know the vertex and edge definition and its usage. And in terms of implementation, there are 2 major ways. The first one is adjacency matrix. The other one is adjacency list. Once you learn and practice these 2 types of implementations, the last one is the graph traversal. It's very similar to what you learn in the tree traversal. We just need to know how to go through each node in a graph in its own way. So graph is also an advanced topic which requires more time and more practice. Next, also is our final topic. I would recommend everyone to take this topic as the last step. Dynamic programming, DP. So in a nutshell, dynamic programming is divide and conquer plus memorization. In a given dynamic programming question, you first need to divide the question into subproblems and solve the subproblem with an answer. Then store those information in memory and then reuse all those subproblem answers again and again. That's basically what dynamic programming is. And also for our learning purpose, how we can link graph to dynamic programming. If you remember, in the graph we mentioned a specific type of data structure, which is DAG. DAG stands for Directed Acyclic Graph, meaning it has a direction and there's no circle. So in this type of data structure, everything moves forward and even some nodes can be processed in parallel. This is a perfect data structure to solve a dynamic programming question because it provides a great performance. However, when it comes to dynamic programming, it's not a clear concept and there's no clear steps to follow to solve a DP question. So to be honest, to master dynamic programming, we need a lot of practice, one question after another. So now we've understand the concepts in theory. It's a good time again to leverage LeetCode question with easy level to get some hands-on practice. Once you've done this practice on LeetCode, you'll get a better understanding for sure. And up to now, I would say the time you spend on this learning path has been like 5 to 6 months. Then, let's go from the very beginning all over again, but this time, we will level up. Find a LeetCode question with medium level on the basic topic, then on the tree topic, hashing topic, balanced topic, graph topic, and the dynamic programming topic. And up to now, it's around like 8 months, I would say. You should be all good if you are interviewing a typical company. However, if your goal is to get into super big company like Google, Amazon, Meta, or Apple, then it is kind of required you practice on the highest level of LeetCode questions, which is the hard one. They are very difficult and they are very time consuming. However, in a typical interview cycle, you will get 3 to 4 technical questions. If one of the questions is a LeetCode hard question and you are not prepared, you will not be able to get into your dream company. And practicing on the LeetCode hard question is very time consuming. I will say you will need to take another 2 to 3 months. After you follow this algorithm learning path, it's about like 6 to 12 months, depending on how much time you decide to invest it. If you invest more intensely, you can get it done in 6 months. If you just do it on weekends, it will probably take you up to 1 year to finish all those topics in the LeetCode questions. So here are the 6 topics in orders I would recommend anyone who wants to master algorithm to take. This order of learning path is closely connected. The knowledge you learn in the current topic will be leveraged in the next one substantially, and this helps your learning to be more effective. In the next video, I'm going to introduce what is algorithm and what is data structure in a very clear and simple way. See you next time.